Hi, my name is Andrew Wood. I am a graduate from Cal Poly Pomona with a degree in computer science. I am a member of the Kellogg Honors College, and I worked on this project under the guidance of Dr. Adam Somerville. This project is titled Understanding Boss Battles, a Case Study of Cuphead, and the focus of the project is determining what makes a boss battle in a video game good or bad, what makes it enjoyable, what makes it frustrating. And we did that through gathering real player experience and doing some analysis on boss battles. We decided to stick to the domain of Cuphead, a specific game of a specific genre. That way we can limit confounding factors that we might see between bosses of different genres. In our approach, we first gathered real player experience feedback through online surveying. We went on forums and asked some people that are passionate about the game Cuphead what their experiences were with different bosses. We asked them in particular for which bosses they found the most enjoyable and which ones they found the least enjoyable. We asked them to rate these favorite and least favorite bosses on 6 different aspects of the bosses. We call these 6 aspects aesthetics in our research. We determined that these 6 aesthetics might have some impact on player experience, so we wanted to get ratings of them for the favorite and least favorite bosses. Right here is a chart sort of depicting that. And then we also created an ontology. Our ontology is not a set of attack types that exist in the game, but rather a set of attack type attributes. So these attributes seen here, this list of attributes can sort of define an attack and most of the aspects of it. What the ontology defined, we looked at the 2 favorite and least favorite bosses according to the survey, and we broke down all of the attacks of those 4 bosses. We did some static data extraction to gather the information on all of these bosses and sort of define their attacks, basically filling out the list of data points for each of the attacks for each of the 4 bosses. Once we had all that data on all of the attacks, we decided to cluster the attacks. We did this using a Bayesian-Gaussian mixture model. Essentially, it's a model where you feed in some data, such as all of our attack point attributes, and then the model sort of sorts through them and clusters the attacks into similar attack types. So this one found 15 different attack types. You can see on the chart, the bottom right is some of the bullet-like attacks. They're small, they move fast, they move predictably. As we follow the chart upwards and to the left, you'll see that the attacks get more varied in how they react and how they work. As you move upwards, some of the attacks are bigger, maybe they move a little bit slower. As you move more towards the left, they get even crazier, with some of them spanning the entire screen, some of them having very erratic movements, and then at the very left side you see mainly the bosses themselves. They're considered an attack because they can damage the player if the player touches them, but they are very unique in their size and the way that they work. So with the attacks clustered, we decided to define the bosses as bags of attacks. So one boss might have 10 different attacks, 2 of them from cluster 2, 3 of them from cluster 5, etc. And so that's how we define a boss. Once we have our 4 bosses defined, we ran multinomial regressions to correlate the player feedback on the aesthetics with the attack types. So we did a regression for each of the 6 aesthetics to predict which attack types have the most impact on what rating those aesthetics get. So right here we have a table of the model's predictions for all 6 of the models and all 4 of the bosses. Each of the correct predictions, the predictions that match the mode of the player experience feedback, are in bold, so those are correct predictions, and then the incorrect predictions are not bold and they have in parentheses the survey results for what the average rating was for that boss. You can see that the models correctly predicted 20 out of 24 of the ratings. That's about 83% accuracy. So that's pretty good, we thought. Certainly the data could be improved. We can make these models a little bit better, maybe change up our ontology a little bit to gather some more meaningful information. But that is work for the future, and we found that these results are pretty promising for bosses in general. Overall, the results of the study are promising, and we hope to continue research like this in the future, and we hope that people put more effort into researching boss battles and video games in general, as they're an area that haven't really been researched much in the past, not as much as things like video game levels, but the AI and machine learning applications are certainly there. Thank you for your time.